Welcome back. Sorry for the minor delay. Okay, there was some technical error, but our technical team took care of that. So, welcome back to this monsoon series. Okay, so let us not waste any further time and then start the class. Okay, so welcome Bhaskar, Rajashri, Ans, Diya, Mukul, Jayas, Naman, Survi, Samriddhi, Bipul, Kartike, Lakshmi, and Naivedya. Thank you for waiting for me. Okay, so let us start the class. So today we are going to see an important topic, that is Marshall mix design, which is included in chapter Pavement Materials of your highway engineering. Okay, so before that, a small recap of what we have covered this week. We have covered traffic delay model, vehicle damage factor, floating car method, vertical curves, and today we are going to see what? Marshall mix design. It's a very regularly asked topic in the GATE. So therefore I thought let me cover this and solve some basic numerical which will help you to excel in your upcoming GATE exam. Okay. So time for the best comment. Every day I take the best comment of the previous class, and this time I chose Mr. Akshay Sukla's comment. Okay. So he has very beautifully summarized the whole lecture. Okay. He has very beautifully summarized the whole lecture. Yesterday we took vertical curves. Okay. Yesterday we took vertical curves. And Akshay has very nicely summarized what is the summit curve, what is a valley curve, then all the important points of PVC, PVT, PVI, then the deviation angle, right? Then the equation, okay, the length of summit curve. Actually, Akshay explained in such a nice way, but the comment was so big that I was not able to put in a single frame. So you see, then he explained about length of curve. Many things he has explained very nicely. So very nice work by Mr. Akshay. Okay, welcome Anis after so many days. Welcome. Good morning, good evening, Anis. Okay, so let us start the class. So thank you, Akshay. And other students also have commented very beautifully. So keep commenting. Okay, so today's lecture also, whatever is covered, please write in the comment section that the summary of the lecture, and also I'll give some homework questions also. Okay, so let us start. But before that, on 7th of August, we are having a scholarship test. So I'll request all of you that you can register for this scholarship test where you can get up to 90% scholarship, and this you have to go to BYJU'S Exam Prep app, and there you have to register for this scholarship test. Okay, and from Monday we are starting what? The previous year questions and the related concepts of your GATE examination. Okay, so please attend that also. I will be taking fluid mechanics in the beginning and then irrigation also, and other teachers will also take other important lectures. Okay. So now let us start with a bitumen mix. Okay, let us not waste any time and start is what is a bitumen mix. Now, when we are going for your flexible pavement, we know that we have bituminous mix, right? In flexible pavement, we use what? Bituminous mix. Now, please write in the comment section, in the bituminous mix, what are the constituents? In the bituminous mix, what are the constituents? Please write in the comment section, what are the constituents of a bituminous mix? What are the constituents of a bituminous mix? Please mention in the comment section. Whatever comes to your mind, please mention in the comment section. What are the constituents of a bituminous mix? I'll wait for a comment, then I'll proceed. Yeah, somebody is writing bitumen and aggregates. Aggregates plus bitumen, yes, yes. Filler, very good, very good. Many people are commenting, very good. So first of all, it will have some bitumen, right? First of all, it will have some bitumen, okay? And then we'll have what? Then we'll have your aggregates. Then we'll have aggregates. In aggregates, we will have coarse aggregates. We'll have coarse aggregates, okay? And then your fine aggregates. We'll have your fine aggregates, coarse aggregates, and then we'll have our fine aggregates. Okay. These coarse aggregates and fine aggregates, I'll put them in one category of aggregates. Suppose I'm putting them in one category of aggregates. Okay, one category of aggregates. Okay. Then we'll have some filler material like sand and all. Okay, we'll have some filler material, that is sand and all, and then will not want any air, okay, but there will be some air, right? We don't add the air, but air will be by default present, right? It will be by default present, yes. So all these constituents will be there. Now I'll be giving different notations to them. Okay, so this bitumen have a weight of WB and it will have a volume of VB, right? Now this coarse aggregate and fine aggregates will have different type of there might be different types of aggregates, coarse aggregate, different types of fine aggregates. Okay, this filler. So I will name them as what? A1, A2, A3, like this. I'll name them like that. Okay, and then I will say that their weights will be W1, W2, dot dot dot, and then their volumes will be V1, V2, dot dot dot, right? Now air will have only volume. Yes, air will have only volume. It will not have any weight. Will not consider the weight of air in the calculations. Okay, so this is, I can say, the constituents. I can say the constituents of a bituminous mix. Very good. Now what is specific gravity? We know that specific gravity is the unit weight of a particular substance divided by the unit weight of water. Unit weight of water. Now, if I take the unit weight of water as 1 gram per cc, if I take the unit weight of water as 1 gram per cc, means expressing the unit weight in gram per cc, then I can say that the G will be numerically equal to what? The unit weight. And what is unit weight? Unit weight will be weight by volume. Weight by volume. So from here I can say the volume will be equal to weight by G. The volume will be equal to weight by G. Yes. So from here I am saying the volume will be equal to weight by G. So if I take for the bitumen, I can say this VB will be equal to what? The weight of bitumen divided by what? The specific gravity of bitumen. And similarly I can say the volume of these aggregates individually will be what? The weight divided by what? The G. Divide the G. Okay. Welcome Ankur and Manjunath. Okay. Similarly I can say V2 will be equal to W2 by G2. I cannot say that for air because air don't have any weights, will not consider in that way. Okay, will not consider in that way. Now, we'll come across a term known as what? Theoretical specific gravity. Theoretical specific gravity of the mix. Of the mix means what? Of the total one. The theoretical specific gravity, G theoretical of the mix. Now, how I will find out the G theoretical of the whole mix? I will take the total weight, right? And then divide by total volume. Total weight divided by what? Total volume. Yes, because in the previous slide only we saw that what is G? What we saw? We saw that G is equal to W by V. Yes, so total weight by total volume. Now what will total weight? It will be the sum of individual weights. So I can say the weight of bitumen plus the weight of different types of aggregate, W1, W2, W3 and dot dot dot. Means how many aggregate types are there till that time. Not type, that we can say type. Okay. Then we have total volume. Total volume will be what? Volume of bitumen plus the volume of individual aggregates. Volume of individual aggregates. Now we have seen that. What is the weight? What is the weight? Total weight. It will be sum of these things. So I can say, here I can write down summation of different weights. Total weight is summation of different weights. Now see, when I write this volume VB, what will be VB? It will be weight of the bitumen divided by G of bitumen, right? Then what will be V1? It will be W1 by G1. This only we saw, right, in the previous slide. In the previous slide, this only we saw, right? The volume of what? Weight by specific gravity. Weight by specific gravity. So I can write like this. I can write like this, right? And then dot dot dot. So can I say this theoretical specific gravity of the mix is actually equal to summation of weight divided by what? Summation of the ratio of weight and specific gravity. Can I say like this? Yes, I can say like this. So this is, ladies and gentlemen, what? The theoretical specific gravity. I can summarize. The theoretical specific gravity is equal to summation of weights of bitumen and individual aggregates and divided by summation of the weight and G. Summation of weight and G. Understood everyone? Yes, everybody has understood. Everybody understood. This is a theoretical specific gravity. The theoretical specific gravity. But this theoretical specific gravity has a problem. What is the problem? You see, this is total weight. This is total weight by total volume. Total weight by total volume. But you see, when I took the volume, I only took the volume of aggregates and your bitumen, right? I took the volume of only aggregates and bitumen. I didn't take the weight of what? The volume of what? The volume of air, right? Remember? See, these weights are what? These weights belong to aggregate or bitumen because air don't have any weight. So, I have ignored the volume of air. So, I can say, since I have ignored the volume of air, I can say that this theoretical one is not the actual one. This is not the actual specific gravity. It is not the actual specific gravity of mix. So how to find out the actual specific gravity of the mix? Very easy. What we do, we have this mix. Suppose this is our mix. This is our bituminous mix. Okay, this is our bituminous mix. Okay, so you have added all the things with what? The aggregate, the bitumen, and then the filler, everything is there. So this is the mix. Okay, what we'll do, we'll take a part of it. We'll take a part of it and we prepare a sample. We prepare a sample. Okay, a cylindrical sample we prepare. Okay, a cylindrical sample will prepare. Now, this sample will prepare inside a mold, right? So, what will be the volume of this particular sample? The volume of sample will be equal to the volume of the mold, right? Yes. If you are preparing inside a mold, then this volume of sample will be what? The volume of mold. At the volume of mold that you will be knowing, right? Or if you don't know, you know the dimensions of this particular cylinder, then you can find out the volume of mold. Yes. Then what you will do? You will take the weight of this particular sample. You can take the weight of the particular sample, right? So now you have the volume of mold, then you can get what? The volume of sample, you have the weight of sample, right? Now this sample will contain everything, right? This sample will contain what? The coarse aggregate, the fine aggregate, the bitumen, even the air, right? Sample will contain the air. So when you're taking this volume, you are taking the volume of air also, right? Yes, because in the total sample, you're taking the total sample volume. So inside that air volume is also calculated, right? Or we can say not calculated, included, right? Yes. So I can say that here, if I find out the G by taking what? Weight of the sample in which everything is there, and then volume of the sample where everything is there, then this will give me the actual one. So this will give me what? The actual one. I will call this as the specific gravity of the mix. Everybody understood how we are finding the specific gravity of the mix? The actual one, yes, the actual one, and how I am finding the theoretical specific gravity. Theoretical specific gravity. Now tell me which one will be more, tell me. Which one will be more, theoretical or your actual one? GM. Suppose I name this as GM. Tell me which one will have larger value? GM or G theoretical? Which one will have larger value? Please mention in the comment section which will have larger value, G theoretical or G min or G mix. The theoretical will have larger value. Yes, the theoretical will have larger value. Why it will have larger value? Because you see, when I am taking the theoretical one, I am taking the weight of only the solids, right? I am taking the weights of only solids, right? See, if you consider bitumen also as solid, suppose I am assuming that to be a solid, so you are taking only the weight of solids, right? And in denominator also you are taking the volume of solids only. Volume of solids only. Okay, this is your theoretical one. But when you are taking for the GM or the actual one, here what you are doing, you are taking the weight of sample, it will contain the weight of solids, right? But when you're taking the volume of sample, it will contain the solids also and the air also. It will contain the solid also and air also. Now you see, if you compare these two equations, GM and G theoretical, you can see that the numerator is same, but the denominator is more in case of GM. The air volume is also included. So I can say the theoretical one will always be greater than the GM. Now this question arises now. So if this is the actual one, why at all we are finding the G theoretical? Yes, if this is the actual one, then why at all we are finding the G theoretical? The answer is to find out the percentage air void. Now what is percentage air void? I'll denote it as percentage air void, so VA. And how we calculate that? That is the volume of air. That is the volume of air divided by total volume. Divided by what? Total volume into 100. Divided by total volume into 100. So how to calculate this? Very easy. This is, the formula is for VA percentage is your G theoretical minus GM divided by G theoretical. Yes. And why we are taking this formula? Let us just derive it in small time. Very easy. See, G theoretical, what I told, weight of solids divided by what? Volume of solids. Air volume is not considered. Now GM is what? Weight of solids divided by what? Volume of solids plus volume of air. I include the volume of air in GM, right? Divided by, you see, G theoretical is what? Weight of solids by volume of solids. So you see, the weight of solids is getting cancelled everywhere, right? So if I do some mathematics here, this will be what? Vs plus Va minus Vs divided by Vs into Vs plus Va. This is the numerator, right? Divided by 1 by Vs. You see, Vs gets cancelled here. Vs will cancel here. You see what you're getting? You're getting this, na? You see what you're getting? You're getting volume of air by volume of solid plus volume of air. Now, volume of solid plus volume of air is what? Total volume. And Va is what? The volume of air. Understood? So I can say from this short derivation, I can say that your VA percentage, okay. See, when I say percentage air void, sorry, something fell in my eyes. Just give me 1 minute. Okay, it's fine now. Okay. So this percentage air void is what? It is by volume, right? It is by volume. Means what? Volume of air by total volume. So this is nothing but G theoretical minus GM divided by G theoretical into 100. Understood, everyone? Very good. This is how we find out what? Percentage air voids. The next term is percentage bitumen. Okay, I'll name this as percentage VB. Now this is also by volume. This is also by volume. So what will be the definition of this? The definition here will be the volume of bitumen. The volume of bitumen. Okay, the derivations are not that important, but it will be easy for you to remember the equations, right? And I think that this derivation is helping you to remember the equations. So volume of bitumen divided by what? Total volume. Divided by what? Total volume into 100. Right? So what is the volume of bitumen? I can write this as VB by what? Total volume. Now see, volume can be written as what? Weight by specific gravity. So here I can write down weight of bitumen by specific gravity of bitumen divided by what? The total weight. See, V is what? Total volume. So in place of total volume, I can mention what? The total weight by what? G of the total one. G of total means what? G of the mix. And total mix specific gravity is what? GM, right? It is GM. Yes, it is GM, because in denominator I am taking the total one. So I'll take the G of the mix, right? Why I am not taking G theoretical? Because that is the wrong one. GM is the actual one. But why we found out G theoretical? To find out the air voids. That is the only job of G theoretical. Okay. So from here I can say WB by the total weight into what? GM by GB. GM by GB. So this is one formula, okay, this is one formula. This is another formula. This is another formula. Yes, for finding what? The percentage bitumen. Now see this. See this. Yes. Can I say this is nothing but the percentage bitumen by weight क्या? This is percentage bitumen by weight. This is percentage bitumen by weight. Weight of bitumen by total weight, yes, into 100. So from here I can tell another formula that the percentage bitumen by volume is equal to percentage bitumen by weight, percentage bitumen by weight, percentage bitumen by weight into GM by GB. So we have two formulas and they can ask a very simple question. For example, they will give that percentage bitumen, they will give percentage bitumen by weight is 7%, is 7%. Find the percentage bitumen, find the percentage bitumen by volume, and the data is given GB is equal to 1.05 and GM is equal to 2.5. So find out this answer. Very simple question they will ask like this, right? This relationship, one relationship is this, one relationship is this, what? This is equal to VB by total volume into 100. Okay, another relationship is what? Weight of bitumen by total weight into GM by GB into 100. So from here I am getting this particular relationship. Now tell me what is the answer for this? What is the answer for this? Let me find out also. It will be 7 into 2.5 divided by 1.05. Getting 16.67. Getting how much? 16.67, right? Simply what I did, it is percentage bitumen by weight is 7% into GM is 2.5 and GB is 1.05. GB is what? 1.05. So this is how much? You're getting 16.67%. Understood everyone? Such kind of very simple questions are asked in the GATE examination, but if you are not knowing the basics, then you will feel that they are very tough questions, right? If you don't know the basics, then you will feel that it is very tough question. But people who are knowing the basics like you, okay, because you are learning nicely over here, then you will not face any difficulty in solving such type of questions. Understood? Why are others not answering? Why only Karthik answered? What are others doing? Are they sleeping? Or they're busy, just sleeping, they're not calculating, they're just, seeing this particular video as a movie. Okay? Why they're not answering? Okay, you don't want to reply also? No problem. See, I am telling you, if you are seeing these videos, then please sit with your calculators, okay? Because GATE is a numerical based examination. They will ask you 95% numericals, okay? So if you are just seeing these videos as you know without using calculator and all, then I can surely tell that you will be knowing the answers. You will be knowing the answers, the formulas and all, but in the examination you will commit mistakes. Because these things requires practice. Okay, therefore you are conducting the sessions and I expect that you sit with the calculations and answer the calculations. Okay, so again I am telling you, not only in my class, in other teachers' class also, if you are appearing for GATE examination especially, I want you to please solve the questions while the class is going on. Then only you will be benefited immensely. Okay? Okay, very good. Next is VMA. What is this VMA? This is voids in mineral aggregates. This is what? Voids in mineral aggregates. This is the voids in mineral aggregates. Okay? Voids in mineral aggregates. Now, how you find this voids in mineral aggregates? This is what? The total voids. This is what? The total voids. The total voids is what? Total void percentage. See, in the voids, See in the voids, what will be there? In the voids, either air will be there. In the voids, either air will be there or what will be there? There will be what? The bitumen, right? Either air will be there or there will be bitumen. Okay. So, air percentage is what? VA percentage. Bitumen percentage is what? VB percentage, right? So, what is your total one? The total one will be equal to the air percentage plus the bitumen percentage. Yes, it will be the air percentage and the bitumen percentage. Understood? So, they ask you VMA. If they ask you VMA, then be assured that if you have got your VA percentage, we know how to find out VA percentage. This is the theoretical minus GM divided by your GM, not GM, G theoretical, okay, into 100, okay. And you know how to find out this? We just saw, okay, write on the formula, weight of bitumen by total weight into what? Your GM by GB into 100, right? So if you know these two, then you can easily find out what? The VMA voids in total voids in the mineral aggregate. Very easy thing, right? So the next thing is VFB. What is this? This is the percentage void filled with bitumen. Filled with bitumen, okay? Filled with bitumen. Now this is very easy. Now you see, total voids is what? VMA, right? And how many are filled with bitumen? That is VB percentage. Okay. So VB percentage by VMA percentage into 100 will give me what? VFB. So what is your VFB? As I told, it is what? Voids filled with bitumen. Means what? Out of total voids, how much voids are filled with bitumen? Now this is what? This is your volume of voids plus volume of air voids, I can say, air voids, okay. This percentage plus what? Your VB percentage. This is total one. And out of this much is filled with bitumen. So this into 100 will give me what? VFB. So give me what? VFB. Understood? Very good. Let us summarize and solve some questions, and also I'll give you homework question. Okay, the summary is, first of all, we saw that we can calculate G theoretical using what? Take the summation of weights, divide by what? Summation of weight and their specific gravity. What is GM? We will prepare a sample, take the weight of sample, divide by what? Your volume of sample, right? Divide by volume of sample. This is the theoretical and GM. Then you have to calculate what? The VA percentage. This VA percentage or air voids is also somewhere written what? VV. Some books also write VV. Okay. So they writes VV means what? Voids or air void. It is same. This is belonging to air voids. Okay. So this will be what? This will be equal to, I can say, G theoretical minus what? GM by G theoretical. Okay. Into 100. You can remember this in this way also. See G theoretical by G theoretical will be what? 1. So 1 minus GM by G theoretical into 100. Into 100. This will give me what? VB percentage. Now, next is VB. Right? VB. This is what? It is simple. Weight of bitumen by total weight into what? The specific gravity of bitumen by the specific gravity of the mix into 100. Right? Now, once you get these two, then there are two other things. VMA, which is sum of what? VMA is what? It is sum of the air voids and the voids of bitumen. And then there is voids filled with bitumen. That is voids filled with bitumen divided by what? Means percentage bitumen divided by the total voids. Okay, into 100 to get in percentage. So using this, we will solve a question. Let us expect that you all are woken up. Okay, I expect that all of you are woken up. Okay, and you are not with your calculators. You are not with your only sleeping on the bed and seeing the thing as a movie. Okay, so I expect everyone to answer the questions. Okay, I expect everyone to answer the questions. Okay. See, if you are just seeing this as movie, I can assure you that you will not be able to score good in GATE. I am again and telling the same thing, that this is a very numerical based examination. If you are not solving numericals, you will not be able to score good in GATE. Write it down in a piece of paper. Okay. So let us solve a question. You see, this data is given for a mix. This data is given for a mix. And from the mix, we are preparing a Marshall sample. This Marshall sample is the bituminous mix sample. This is known as Marshall sample is known as what? Bitumen mix sample or bitumen Marshall mix sample. Okay. And the weight is this, the volume is this. That means what? This is the weight of sample. This is the weight of sample and this is the volume of sample. This is the volume of sample. Okay, this is the weight of sample, this is the volume of sample. Okay, so now if I am preparing the everything, means I am asking you to answer everything. So how will answer? How will answer? First of all, I am asking you G-theoretical. How to answer G-theoretical? It is the total weight. Okay, nobody is commenting because they are busy with some very important stuff they are doing. Okay, this all the students are not answering. I don't know why. Okay, so I will not see the comment section. I will just solve. Okay, and go. Okay, very good. Na, very nice. Na, you have made me very happy by not commenting in the comment section. Okay, very good. Great. I am very happy that you have done very good thing. Okay, again I am telling, if you don't comment in the comment section, then don't expect me to solve numerical sessions. Okay, many students are telling, sir, please come and take this, that. Okay, but if you are not solving questions in the class, then what is the use of taking the sessions? Yes, what is the use of taking the sessions if you are not solving in the class? Right? If you are not solving in the class, then what is the use of taking the sessions? Again, I am telling you, if you are thinking this is some theoretical examination of some, memory based examination, then you are in a fool's paradise. I am again and again telling you that if you want to score good in GATE, you have to solve numericals. If you are not solving numericals, you are just sitting in the class and just seeing the steps. See, you will be able to remember the steps, but in the examination, you will commit mistakes. Okay, chalo. So G theoretical is what? The total weight by total volume. Total volume is what? Summation of weight by G. So first of all, the total weight is how much? 90 plus 600 plus 900 plus 410. This is total weight. How much I am getting total weight? Total weight is how much? I can say this is 500 plus 15, 2000, right? Total weight is 2000 gram, right? 2000 gram. Divided by what? For the bitumen, it is what? Weight of bitumen by specific gravity of bitumen, right? Weight of bitumen, specific gravity of bitumen. Then weight of coarse aggregate, specific gravity of coarse aggregate. So 600 by 2.65 plus weight of fine aggregate, then your specific gravity of fine aggregate. So 900 by what? 2.54. The last one, 410 by 2.48. Understood? So it's very simple. It's very simple. G theoretical is very simple. Take the summation of all the weights. Take the summation of all the weights in the numerator. And denominator, what you do? You take the summation of what? Weight by specific gravity. You see, weight by specific gravity. See, weight by specific gravity, weight by specific gravity. So numerator, sum of all weights, divide by this. So how much are getting G theoretical? Some students have calculated after getting some scolding. Okay, very good. I like to scold because scolding brings the best out of yourself. So it is 2.4. I'm getting how much? The theoretical specific gravity I'm getting 2.4. Okay, all of you are getting 2.4? Yes, very good. Now the next thing is I need what? The GM. That how I'll calculate? The weight of sample by volume of sample. The weight of sample by volume of sample. Yes. Weight of sample by volume of sample. So what is the weight of sample? It is given how much? It is given 1040 and then 460. So 1040 divided by 460. How much are getting this? 1040 by, so GM Karthike is telling 2.26. 2.26. Okay. GM is 2.26. Okay. 2.26. So now, as I told before also, G theoretical will come more than GM. You see, this is coming 2.26. It is coming 2.4, right? So first, if I am interested in finding out the percentage air voids, if I am interested in finding out the percentage air voids, what will be the value? It will be 1 minus GM by G theoretical into 100. Gm by G theoretical into 100. So how much I will get? 1 minus 2.26 by 2.4 into 100. So how much I am getting? Please tell in the comment section. Percentage air voids, how much I am getting? 5.83. Very good. I am getting it to be 5.83. So this is your percentage air voids. So you see these questions are appearing simple, but in the examination they ask this only. They will ask you these questions only. Okay, whatever we are solving in this numerical session, they will ask you that question only. Okay, this is your VA. Then VB. Now VB percentage was what? The volume of bitumen, sorry, the weight of bitumen by total weight into G of bitumen by G of mix into 100. Now what was the weight of bitumen? It was 90. Total weight how much we got? Adding all of them 2000. And GB how much was there? GB was, the specific gravity of bitumen was 1.03. It was 1.03. And then for the mix we got how much? 2.26. So what is the answer here? What is the percentage bitumen? Please answer in the comment section. How much I am getting? Percentage bitumen, how much I am getting? .05. Let me calculate. Let me also calculate. 90 divided by 2000, okay, into 1.03. Oh, sorry. It is GM by GB. Therefore, I was thinking something is wrong. It is GM by GB. Sorry. It is GM by GB. That's what I was thinking, that something is wrong. So, it is 2.26 divided by 1.03. Okay. That's what I was thinking, that something is wrong about this. So, if you calculate now, you will be getting 9.87. You will be getting what? 9.87. So, this was a small error. And how to remember this? See, we saw the basic definition was what? Volume of bitumen. Volume of bitumen will be what? Weight of bitumen divided by G of bitumen. Then total volume is what? The total weight by the G of the total mix. Okay. So, getting how much? 9.87. So, we got your VA, right? And then, or VA or VB, I can say this one, percentage air voids. And then we got what? Your percentage bitumen also. So if I ask you the total voids in mineral aggregates, that will be how much? Add this to 9.87 plus what? Plus your 5.83. Plus your 5.83, right? This is the air one, this is the air one, and this is the bitumen one. This is the bitumen one. Okay. So how much you are getting this total? Tell me. How much you are getting total? Tell me. 15 point, almost I can say 15.7. Almost I can say 15.7 I can say percentage. Almost I am getting 15.7. Right? Almost I am getting 15.7. Right? Now, how to find out? I am getting 15.7. Very good. Now, how to find out the VFB? That is also very easy. That will be equal to what? That will be equal to the volume percentage of bitumen divided by the total void, that is 15.7. So in 200, how much I am getting this value? How much I am getting this value? Please tell. So in this single question, actually I covered everything. Almost everything I have already covered, right? In this single question, I have covered everything. 62.87. 62.87. So you can see that in the examination, they will not ask you everything, but you now know how to find out VFB, you now know how to find out VMA, you now know how to find out VB, and then air voids. Now they can ask you some other questions also related to these formulas, like this question. So it is given the percentage air void is given 8%. So this is what? This is your VB, or I can say VA percentage. What is asked? It is asked to find out the unit weight of bitumen in gram per cc. How to find out unit weight of bitumen? If you can find out GM, you can find out the unit weight, right? Because GM is what? Gamma by gamma W. So if you can find out GM, you can find out the unit weight gamma, because you know the unit weight of water, right? 1 gram per cc. Yes. So for that, you see, what is percentage air voids? Percentage air voids is actually equal to G theoretical minus GM by G theoretical. Okay, G theoretical into 100, right? Into 100. So if you can find out this G theoretical, if you can find out this G theoretical, sorry, if you can find out this G theoretical, okay, G theoretical, you know this, you can find out GM, you can find out GM, right? You can easily find out GM. So first of all, you have to find out G theoretical. Now here you see the weights are not given, the percentage is given. The percentage is given. So if percentage is given, what you do? You assume total weight to be what? You assume total weight to be 100 gram. If total weight is 100 gram, so fine aggregate will be 24% of this, that is what? 24 gram. Coarse aggregate will be 70% of that, that is what? 70 gram. And your bitumen will be 6 gram. Yes. Now you can find out G theoretical. G theoretical will be what? The total weight is 100. Then what? The ratio of weight and specific gravity, that is what? 6 by 1 plus 70 by 2.8, right? Plus 24 by 2.66. So how much G theoretical you are getting? Please mention in the comment section. How much G theoretical you are getting? Please mention in the comment section. G theoretical, how much you are getting? Please mention in the comment section. How much G theoretical you are getting? You are getting 2.498. You are getting 2.498. Very good. You are getting 2.498. Others also please contribute. Okay. 24 divided by 2.66. Okay. Then plus 70 divided by 2.8 plus 6. Then divide this by 100. Yes, I am getting 2.49 almost. I can say 2.49. I'll round it up to, even I can round it up to 2.5 also. Almost it is 2.5. So G theoretical is 2.5. Now the percentage air void is 8%. So 8 is equal to, I can say, 2.5 minus GM divided by G theoretical, that is 2.5 into 100, right? So if I divide, I'll get 0.08 is equal to 2.5 minus GM by 2.5. So how much GM you are getting? Find out. I'll find out. Since many are sleeping, so I'll find out. 0.08. I'm getting 2.3, right? I'm getting GM as what? 2.3. Okay, GM as 2.3. So I'm getting GM as 3.3. Means what? The specific gravity of the mix I am getting as what? 2.3. So this is the unit weight of mix by unit weight of water. So if I am interested in finding the unit weight of mix, how will find out? You will multiply what? Unit weight of water. So now if the question is asked in gram per cc, so I'll multiply what? I'll multiply 1 gram per cc, I'll get what? 2.3 gram per cc. If the unit weight is asked in kilonewton per meter, so I'll multiply what? Gamma W is what? 9.81, and I'll get how much? 2.3 into 9.81, I'll get a value of 22.563 kilonewton per meter square, right? If they ask you the question in kilogram per meter cube, so the gamma W in kilogram per meter cube is what? Multiply by 1000, this is what? 2300 kilogram per meter cube. So once you get your GM, yes, once you get your GM, then you can find out what? Your unit weight of the mix in terms of gram per cc, kilonewton per meter cube, sorry, and then kg per meter cube. That depends on what units they have asked. Okay. Now a small GATE question. You see, very easy question, a very, I can say, simple question which is asked in GATE. Okay. See, VMA is given and then VB is given. They're asking you VFB. Now what is VFB? Volume voids filled with bitumen. That is what? The percentage bitumen divided by what? VMA into 100. Now how to find out this? Percentage bitumen will be what? The total voids minus the air voids. That is what? 15 minus 4.5 giving me 10.5, right? So here I will put 10.5 divided by 15 into 100. So you can see that once you are getting these formulas, okay, and the logic behind them, you can easily solve all these kind of questions, right? Once you get the logic behind them, then you can easily solve all these kind of questions. Coming how much? 70% is coming how much? 70%, right? Let me just check. So I'm getting 70%. Okay. So we solved 3 questions. Okay. We saw all the basic formulas of your Marshall mix design. See, Marshall mix design nothing but what? It's nothing but the bitumen mix design, right? Okay. In this thing, what they ask you, all these parameter GTH, GM, VB, or I can say air voids, then VB percentage bitumen, then the total voids, and then voids filled with bitumen. Hope you have enjoyed this particular lecture. So homework time. Now what? Homework time. I will give you 2 homework questions originally framed by me only. I normally don't only solve previous year questions. I frame my own questions. Okay. Even I don't copy from the test series of Delhi or Hyderabad. Okay. I have my own questions. So let us give you some homework. Okay. Let me give you some homework. Okay. So this is the first homework. This is the first homework. Okay. So I can say homework number 1. Homework number 1. Okay. Find VFB. Many data is given. Okay. Enjoy your homework. Okay. And I expect that all of you solve the questions. Okay. And mention the answers in the comment section. Okay, mention the answer in the comment section. I'll give you a small suggestion that whatever is going in your life, please try to manage that, and for the next 6 months, please study very nicely, because you can expect lot of vacancies through GATE in PSUs and in SSC JEE. Okay, and again I will tell you, you cannot crack SSC JEE without studying for GATE. Okay, somebody might be solving only 1 2 easy questions, and they're thinking that they can crack SSC JEE. In the SSC JEE mains, they will ask you good questions, and you cannot solve that if you are not prepared for GATE. Let me remind you again. Many people are not reminding you because they don't want to tell you. Okay, but if you are not preparing for GATE, you cannot crack SSC JEE mains. Okay, so the next 6 months there will be lot of vacancies, and whatever is going in your life, please try to manage that somehow and focus on studies. Okay, don't get distracted to here and there. See, after 6 months, those problems will go, and your preparation will also go. Okay, problems will come, let them come, handle them. You are all now grown-up people. Don't cry like babies. Okay, don't cry like babies. Okay, you are adult now, and you should take your responsibility of your studies. Don't start crying. Any small problem comes, you start crying. No. You should not cry. Be firm, be strong, and study. That will only get you to some good thing in your life. Okay. This is homework number 1, and this is your homework number 2. This is your homework number 2. So 2 homeworks I am giving. I expect that you summarize the whole lecture. Okay. Summarize the whole lecture. First thing is summarize the whole lecture, and then 2 homeworks. Thank you very much. This is the end of class. Okay, we'll meet tomorrow. Okay, we'll meet tomorrow. So now again I'll remind you, on 7th we have scholarship test. If you have any doubt regarding this, you can contact me. Okay, I'll give you some guidance how to prepare for this and all. Okay, plus please do register for the scholarship test and attend the full courses. And tomorrow we have super elevation and camber, very important session. We'll have at 6 p.m. Tomorrow we have class at 6 p.m. Okay, tomorrow we have class at what? 6 p.m. A gentle reminder, every day we had till 5 p.m. All these lectures were taken in 5 p.m. but tomorrow we have 6 p.m. because tomorrow is super elevation. It's an important session. So I've kept at 6 p.m. and we'll have what? Long discussion. We'll have long discussion. Okay, we'll take classes. Tomorrow I will take class from 6 p.m. to I might take class till 8 p.m. We'll solve all the possible things of super elevation and camber. So thank you very much. I expect that you summarize the lecture and also do the homework questions. Thank you very much. Bye. See you tomorrow at 6 p.m.